I gotta buy one?
Buy one, get one free. Get two.
You're not a boy.
What are you buying?
Combustion analyzer.
Oh, yeah. That's a good idea.
You said the company doesn't have one.
Company gives free. That's gonna do after this. You guys have it, right? Combustion analyzer?
We actually handle a combustion analyzer. This is the one I use. It's changed a little bit from this.
He's killing me because he's going to show me something I want to go buy.
Yeah, that's the one I had. That was back in
So
95.
when you guys are setting up equipment, number one, especially if you're converting from natural to propane, you need a combustion analyzer so we can actually check our products of combustion. And when we're doing it, I was asking what you guys do when you convert it from natural to propane. And to convert this boiler from natural to propane, this is just a shipping strap.
Right.
And one of the problems, just by the way, this little hose here, this hose is for bleeding the air out of the heat exchanger. So you don't have to put a big pliers on here. I can actually open this up and purge all the air out. If we don't get the air out of this, it's not going to actually kick on your burner. So you got to get the air out of the heat exchanger itself. And I actually saw one guy, I thought it was pretty cool. He actually just stuck it on here so that it actually lets it. Some guys take it off and they get rid of it. But if I ever have to drain the system and flush it or anything, I want to be able to purge the air. But do not do this. We had a guy down in Maryland. This hose, where the heck? Oh, that goes on here. So he stuck it right on there. And that actually bleeds the air. As the regulator opens, you got to vent the air off the top.
Yeah.
So when he did that, it wouldn't vent the air off. So they're talking to him on the phone, going through. Nobody can figure out what's wrong with this boiler. So they said, okay, give you a new boiler. So he puts a new boiler in.
That's the same thing?
Damn, this hose, second time. So he sticks it on there. Hey, that boiler's doing the same daggone thing. Finally, somebody went out to the job and realized he put the hose on and blocked off his regulator. So this does not go on there. What we do, however, this is my manifold tap. Right there, there's a pressure tap on the manifold. That pressure tap, when this starts up, this little pressure switch measures your manifold pressure, which is negative. What's manifold pressure on a standard gas boiler? Anybody? 3.5.
Yeah.
On these, negative 0.02. 0.02, so I don't really ever check it. There's a little screw in there. If you don't get it to light, you want to check that screw and make sure it's backed out so that you actually get gas out of there when it goes to turn on. And this hose, if I'm not sure if my switch is bad, I can literally jump this out as soon as the blower starts. I can jump that switch. So on this, I'm going to actually it's easier doing my board. Let me do that here instead. I thought I would. My 4 wires here. Okay. So as soon as the blower starts, I could jump this. And now I've proved that your air is flowing. So, and I pulled that little wire off. If you're ever at a job and you want to know whether your blower's working or not, nothing's happening and my blower doesn't start, I can actually disconnect these wires. And there's 2 sets of wires that go to the blower. There's a power wire, a black, a white, and a green. And then there's a 4-wire signal, which is a white, a blue, a gray, and a red. So those 4 wires go to the blower and give it a signal. So if I undo the signal, the blower should run full speed. If it doesn't kick on full speed, I got a dead blower. So I'm just telling you real quick, you can actually, and everybody's equipment's the same way. We're gonna go through on the gas valve, there's 2 adjustments. This little raised portion here, there's a 2mm Allen wrench. That is low fire adjustment. And down underneath here, there's a little throttle screw, that's high fire adjustment. I'll go through that upstairs, but there's 2 adjustments on this gas valve. To convert this to natural to propane, I take these 4 nuts off. I can basically pull my wires off of this. There's a signal wire that we have, you know, that actually measures the flame signal, and there's a spark cable. So I can pull those wires off. And then I disconnect my gas. Now, when you put the gas into this, your nipple's coming straight up the bottom. And what I want you to do is the big part of the union, I want you to screw it so the big part of the union falls down.
Right.
So if you put it right there underneath here where the gas line goes in, you then can just undo the union, shut the valve off, and now I can pull the whole gas. Everything comes right straight out here. Does that make sense? I have a contractor. I said I was putting that boiler in Bethlehem for my nephew. I'm putting one in, but I had a contractor come and do the gas piping. So I took the diagram, circled it. I want the gas put in this way, and I gave it to my nephew. The plumber looked at it and said, I know how to run gas. They don't have to tell me how to do this. He puts the union in over here after the T and everything. So to go service, you got to tear it all apart. So guys think they know, but there's a reason I wanted it that way.
Yep.
And I specifically gave him the copy in the book because I knew he wouldn't find it. And he still installed it wrong. Guys don't like you telling them how to do things. So that was a problem. You go to service this unit, 3 screws come out. And those 3 screws can come out. And I can unplug my wires, and this whole box comes out.
Right.
Your control panel, everything comes right out. Now, be really, really careful. You can reverse this and this. You're not supposed to, but I can reverse them. And then you let the smoke out of the control. So I'm just letting you know.
Yeah.
Okay, so here's what I do. Before I take things apart, I snap a picture. And you snap a picture of it, and then I know the cable with all the gray wires is going in this one, and that one's going in there. So that way I don't have to mess it up.
Yeah,
Just
so
snap a
it's
picture.
1, 2 with a black marker on the bottom part and the top.
Yeah.
Or 1, 1, 2.
I called the factory. I said, you know, you can reverse these. Oh, well, somebody else is going to do it. I can't believe I'm the only one. Fortunately, I didn't do it in front of the class. You know, it was 8 hours of teaching. And then I'm putting it back together. I didn't even think about it. You know, they told me you couldn't mess this up. So, okay, I'm not really thinking of putting it in. Now, here's another thing. Down here on the gas valve, there's a little thing called a rectifier. And my gas plugs right into here. Somebody disconnected the gas, but it plugs in. It's usually a blue and yellow wire. If you ever have a problem, you don't know whether the gas valve's working. We can unplug the wire from the gas valve. And when it goes to light, we can actually check our voltmeter, 24 volts. When it goes through and you get direct ignition, I'll show you upstairs, at that time, check for 24 volts. We have 24 volts there. There's a little screw on the underside. You can pull this box off. What I'm pointing out here is there's a little switch on this, on the side. And you may inadvertently bump that switch and turn your gas valve off. I'll show you, I think I have one up there. I'll show you. There's a little switch on the side. It says I and O. So you have to figure out I and O, it's binary. So the only reason I know, I was on a job and I was doing training and they had a cord and I said, look, it's I and O. One of them's on, one of them's off. And I looked at the cord and it was powered on and it was pushed to the I. So I is on. O is off. So I'm just letting you know. I've actually gone to jobs that worked, and when I went to check it out, I ended up bumping that little switch and I shut it off. And then you don't get the gas valve to light.
That rectifier go bad?
Rectifier can go bad. It's in the service kit. Now, and so you can actually check for your 24 volts AC. When the rectifier comes off, there's 2 wires and then there's a pole in the center. Those 2 pins, 24 volts negative.
Negative, yeah.
So now you can check and see whether that works. What I do, usually when it goes through direct ignition, this will make sense upstairs when I show you this. When you go through direct ignition, I'll feel the click in the valve. So I instead of pulling meters out, I check stuff like that. So I know that it clicks. My blower starts, I can feel the click in here. And when we go to start this up, in the control, and you'll see it upstairs, I can just hit the status button And it actually, right now it says standby. But when it goes to light, you hit that status, it goes through pre-ignition. It actually will go through, it'll do a pre-check for the controls, and then it finally gets the direct ignition. That's when you get your spark. That's when you're going to get your gas valve open, under direct ignition. So if you ever are servicing one of those, and we'll show you upstairs, you just hit that status, so you can see exactly what stage it's in. And if I want to check my spark, don't stand here holding on like this, because you're going to feel it. You know, I want to hold it out here, I can see whether I'm sparking or not. You know, and tell if I get a spark. If you don't get it to light, I got to have spark, I got to have gas, and I got to have where my air isn't, I got to have enough gas. So I can feel the gas valve. There's no air adjustment on this, by the way. The only thing we can adjust is gas. And the gas is adjusted with that little throttle screw down in here. I'll show you in the manual where it is. But when you get a job and you need to convert it from natural to propane, these 4 nuts are going to come out. You're going to loosen the union. The nut's going to drop down. I can take all my wires off and I can pull this whole thing out. We're going to change this little venturi right there. Now, if you do like all the contractors do, is read the manuals and follow their instructions, they're going to tell you to take that throttle screw and screw it all the way in and bottom it out and take it out so many turns. I'm telling you, don't do that. Just put the new part on and light it. Your combustion analyzer, we're going to check the exhaust. We turn it on. What you're going to find is it's going to be a little rich. Not bad. You're probably going to end up, when you increase gas on an appliance or decrease, if I decrease gas on a regulator, do I usually screw it in or back it out?
Decrease?
No, it's taken out.
If I decrease, I usually back out.
Yeah.
This gas valve, it's a needle valve. So you actually screw in. So I actually will take it half a turn in, check my combustion, and you guys, when you use analyzer, do you check CO2 or you check oxygen?
Both. Mine checks both.
Okay, but what do you usually look
I
at?
usually look at oxygen.
Okay, and I like that. That's what I'd look at. Because here's what happens. When you set up combustion, you can actually have, on gas, natural gas, you want about 9% CO2. But you can have 9% CO2 and have 5% oxygen. And you can have 9% CO2 and have no excess oxygen at all. So there's a curve, and you can be, and then you'll be making a ton of carbon monoxide. So if you check oxygen and I have positive number in the oxygen, I know I'm set on the right side of the curve.
Right.
And the other reason I use oxygen is, do you guys set up oil? What do you set oil for?
11.
If you were setting CO2. Okay, 11%. 11.5, 12. I do propane, what do you set it for? 10.5 to 11. And if I set up natural gas, what do I set it to? This is CO2. I'm going to set it up for 9, 9.5. But if I set them all up for oxygen, 4.5 to 5 oxygen. So I don't have to remember what fuel. And if you forget to change your meter to the fuel, if I set it up and it gave me the right reading, your analyzer only has an oxygen sensor. So go with the reading, it converts it. So when you tell it I have propane, it switches to that CO2 and calculates the right CO2. But if I go with oxygen, I got the right stack temperature, I got the right O2 reading. My efficiency calculation is going to be off, but I got the numbers where I want them. So I always go with oxygen. We show you both in the manual. So remember, when you change this part, and it's not that expensive for the kit, put that little part in, save the old piece, leave it on the job, because if they ever get natural available, they now can put it back in and they got natural. So it's great. Or you're selling these, hey, gas is going to be coming down the road now. We're eventually going to have it. Well, we can do propane now, and you can convert it over.
We've also run into where I convert them from oil to gas, but they don't have UGIs 8 weeks, 10 weeks away.
Yep.
So we'll set it up for propane
A tank.
originally, and then
Yeah, it's a great way to go. This is your 3-way valve in here, and you have 2 domestic connections on the other side, my 2 space heating connections. The condensate that comes out of here, you don't seal it directly tight. It's going to be like 1.25 inch pipe that's going to come down. we'll run our hose into there. It's not sealed up tight. Can go down to the condensate pump or go down to a drain, but it's not totally tight. It has an air brake in there. So when we're doing that. These, they have a stack sensor on here. If you're ever working with this and you're not sure what's what, actually let me pull something off that I can actually get to a little bit easier. It's down here at the bottom. Okay, so it has a stack sensor in here, and if you ever came out to the job and it doesn't happen instantly, but you end up getting an error code that's on here, you actually get the help screen that flashes. And we'll do it upstairs, but if you get the help screen that flashes, you just go right through and it actually tells me fault status. And now it has 3 that I can actually put my sensor faults. And it actually goes through and it actually tells me that my my outdoor sensor's missing and I have my header sensor. Oh, not the header sensor. I actually have the stack sensor. So this actually looks at the exhaust temperature. It's doing 2 things. One, it's going to protect so that if we end up having a problem that it gets overfired and my stack temperature goes up, we don't want the stack temperature, we don't want the stack melting.
Right.
So it protects us, it shuts off. That's doing one thing. The other thing it's doing is we actually look at if cold air is coming in, we're actually looking at the boiler if it gets too cold inside. Well, actually that's not the stack, the supply is actually doing that. The supply sensor is actually looking at the temperature in the boiler, and if it gets too cold, we actually turn the pump on and start circulating water so we don't freeze. You gotta realize these go out in Wisconsin, Chicago. You can get cold air coming in, you get a short vent, cold air comes, we can freeze our heat exchanger. So they have frost protection built into this. So it actually, if the temperature of the heat exchanger gets too cold, it actually will turn on the circulator, and if it doesn't rise, it turns on the burner. So it fires it, even if there's no call for heat. So it gives you freeze protection. It's pretty cool. This actually has all your 120 volt wiring is in here. The pump in here is already wired. We need to wire our system pump into this. That's the only pump we end up tying in. So that gets wired right into here, and we bring our power into this box. This has your low voltage connections. There's a connection in here where you can put your limit circuit. I can put my low water cutoff. Do you put low water cutoffs on each one?
Not now.
Okay, there's a flow switch in here. And if we don't have the air out of here, or if this pump's not running, it doesn't fire. So it's kind of like a low water cutoff. I'm just letting you know. Don't know that the local township will accept that, but I'm just letting you know. You have air in this, that unit will not fire. If you don't have flow, it's not going to fire up for you. These side panels can come off. So when you install this, if you put it in real tight, I mean, if you really wanted to get into this thing, this panel can come off the side, and when we come off, it basically allows us to totally get in where this circulator is. This comes out of the way and I can come in this way, but you can take off both sides if you want. We do not require clearance. I'm just letting you know if you want to take it off. I would probably leave some space on this side. I don't normally take this side off, but if I want to take this off, I can.
The circulators that are in it, have you had any fail on you that?
I had one guy that got one dead on delivery.
Okay.
The pump, they test and they fire each one, but not with the pump in. The other thing is they put a lubricant. I don't know what liquid they use inside. It's like it's almost seized up or something. But I had one that we had to do that way. And then when they put the flanges, you can kind of see the flange. It looks like it's really tough, but when I pull this apart, it's not that bad getting in. But when you get to the circulator flanges, they actually put like a grease on there that they slip and slide around. It was a little bit of a pain.
So you're saying if we take that control box, the bottom box out, you can get to that circulator without a problem?
Yeah. I'm gonna, George, can you shut that power off?
Yep.
Oh, actually, she's not firing now.
Like that.
Yeah, she's still on, but she's not firing. So, anybody have a Phillips screwdriver? Or a little screwdriver? And if you ever have a display that goes bad, the wiring diagram actually shows you, in the wiring diagram, we have 5 volts DC that goes to the display. So you actually measure for the 5 volts going to it. If I have the 5 volts going to the display, my problem's the control, not the display. It will work without the display lighting. What I like about the control is it actually has a green power light on it.
Right.
So the green power light tells me my transformer's working. So I know I got 120 to it. I know the transformer's working. The second thing is that it tells me if I'm on lockout, there's an alarm light. So it lets me know that the boiler's locked out. And the other thing that it has, and this pulls off my display, so I can actually pull that out. So I can get this out of the way. So this whole thing can be pulled out. Now my circulator's in through there. Here's the other thing. If you ever had a problem with a heat exchanger, that's all that holds the heat exchanger is some clips and there's some screws. So the heat exchanger, and there's an O-ring. Actually, she just popped out. The O-ring that's in here. You can see the O-ring. I'll stick this back in later, but the O-ring that's in here, they're in the service kit. So if you ever had a problem, I had one guy right when it came out, he had the O-ring that was an issue. So what did they put down in? Oh, that's my gas line. Somebody took this apart pretty good. There's a little bit of a dip switch over here on the side. That's your I and O that you're gonna see. Once you pull this out, you'll have access to the inside. And here's what I do. There's a little peep sight. So when you get it fired up and you're doing regular maintenance, I'm looking in and I look for little sparklies on the heat exchanger, which lets me know I have some buildup on there. So I can take these 4 nuts off and the heat exchanger, the burner side pops right out. You don't need any gaskets or anything to put in.
Now, on a regular maintenance, what do you recommend doing?
Regular maintenance, I would take a look at that and see what it is. I would do my combustion test and see where I am on my combustion. And if I needed to clean it, I'm going to pull these 4 off, pull my wires off, and my ground wire. I'm going to pull this out, and I'm going to spray CLR on the inside and use a nylon or a brass brush and just clean the inside, flush it out with some water, and stick it back in.
Okay.
And do my combustion test and just check and make sure. I want to look at my flame signal, and I'll show you upstairs how you can see the flame signal. Okay. And there's some really neat things you can do for troubleshooting this, but the flame signal on this is really good. The minimum is 0.9, and the maximum, you'll probably get close to 30. So it's a big range.
Yeah.
We don't dual sense. It only senses through the flame rod. Some other manufacturers sense through the spark rod and the flame rod. We just sense through the flame rod.
Now, do you recommend pulling the igniter, or is it just better to pull
the
whole thing?
I don't like to
So
pull
you're not
the
killing
igniter.
those gaskets?
When the gaskets are in the service kit again, but I don't pull them. I like to pull this out and take a look at them from the inside.
Okay.
It's 4 of them. Now the outside of this is a plastic composite on this. It's not metal right on the outside. This is a cool head. So the cool air comes in and it mixes with the gas. And we actually have a gas-air mixture that goes through the center of the burner. So, but I would actually pull that just to take a look at it. I would check my flame signal and see what that is.
Have you ever come across a cracked heat exchanger with one of these?
Not on this style. I've had guys with other heat exchangers. This is taken down from the bottom. It's not coming from the top down in. So being that the pipe's down here, I don't get quite as much dirt and stuff in with these. No, I haven't had really issues with the heat exchanger. And what's really neat is you can buy just the heat exchanger.
Yeah.
That heat exchanger, it's literally just bolted in here, and I got to take my exhaust off. But the heat exchanger, you can pop out of there and change. I'm not saying you want to be changing heat exchangers,
Right.
but you
Every
can.
year.
I mean, I sold condensing boilers for a long time, and the ones I sold before, you couldn't change the heat exchanger. So
And,
that
you
was
had,
kind
and
of
a lot of those cracked too, didn't they?
I got some of them that filled up, and a lot of them because they didn't put the Y strainers. They didn't put the stuff in there that we would use.
Getting blockages more than
Yeah.
this wire here.
Yes.
That sensor.
Now, what they did is on this wire, my hand's all greasy now. This wire, this is your flame sensor. The flame sensor is going down here to the. Can you grab that thing maybe? See if that pulls apart. And you're putting one of these in, do what he just did. Take this wire that goes down to the condensate and take it off. Or if you have one that's out installed and you go out and you're getting flame failures, you should not get flame failures. And this will give you the error codes on what you have. But if you do get flame failures, you can actually look at your flame signal and you can look at it where it lights. And this will tell you whether you're in low fire, you're 20%, you're 60%, so you can see what it is. What happens that when this lights, it lights at a certain ignition speed, which is about 60% of capacity, and then it goes down to low fire. And I've had guys that called me and it lights, and then when it goes down to low fire, I lose my flame. So that's usually telling me when you get less flame, my signal goes way down. So a couple things that I can do. One, I can disconnect that wire, see if my signal stays up. And if that doesn't take care of it, just to get out of trouble, your holiday weekend, I can actually go in and adjust low fire. I'm going to increase it so it's my ignition rate. So now I'll just raise low fire so it lights, stays at low fire, and then it'll go up from there. So I can actually have it. You don't need computer or anything. You go in and make all these adjustments. So we're going to go up and show you some of the adjustments you can make. Most of them are self-explanatory when you go through and take a look at this. But it's, I don't know, it's been very few problems we've run into it. This was the only time that I'm changing something, that orange wire that comes down
So
through.
guys, while we're out here still on this, anything from the standpoint of diagnostic or service that we've run into that we have to review?
We get a lot that make a whistling sound.
Okay, whistling sound, especially if you go to propane. And
Yes.
is the whistling
They're all
on
propane,
ignition?
yeah.
It's on ignition. Okay, there's an adjustment, and we'll show you. I got two boards. We're gonna go from the lowest we can set our ignition speed, and we're gonna go to the highest. You usually get it on short terminations where you're coming up and going right straight out. So what we can
that's
do
that
is
one, too.
you can actually adjust that ignition rate, and you
You're
can,
talking about the pipe.
yeah, the pipe's
And
very
Enriquez
short.
goes right out.
Right out. So you get short, not a lot of resistance. So I can actually change my firing rate at ignition. And when I do that, noise goes away.
What's the default rate they're set at, Rob?
It's about 60 to 65%.
So it's not necessarily the gas pressure or anything like that. It's the
It's the fan speed we're at.
Fan speed.
It's I had one. I had to run down to Maryland, and I went through, and went down, and the first one I had that way, and we just adjusted that fan speed, and we adjusted that. It went right away. Okay, now you guys remember I did this. It was all the gray wires were on the other
You have
side.
your clip.
Huh?
Your clip's behind that.
Oh, for the gas valve.
Yeah.
now the other ones that we've added on wasn't on short.
Right, did you touch base on sage control, zone control with these guys?
I will.
Right out.
Yeah.
'Cause you're not getting
Where was that clip? I'm missing it.
Yeah.
That big clip, right? That big clip down there.
Oh yeah. That one.
Yeah.
Yeah. Let me just stick this on here for now.
Probably 15 after everything's said and done. You weren't on that one.
This is it was like a 10,000 square foot house, and we did two of them in tandem.
Man, they really did take his sucker apart. Different things.
Some of them definitely.
This is the wire I'm leaving off when I do that.
That's how I usually end up.
This one I can't mess up.
On a couple of them.
The gray one went over here,
To the left.
and this one
Blue one to the
went
right.
over here.
Right.
Great, that's it. That's how I got his.
Is the way she went
I
together.
was with him last night.
And this one went
Well,
back
I told
on.
him, I said, we're having training on the K-2s. He goes, good, maybe you'll fix mine.
Oh, the guy down the street.
Now, when we do the off of
Hey, this
this,
has been
if you're
fun.
doing one of our indirects, you need 24 volt power. We can actually pull the 24 volts out of this. There's the 2 end wires on that green plug here. We can actually pull 24 volts and be able to power up our indirect. You can't power 6 zone valves, but we can do our indirect. So there's a little bit of 24 volts we can end up getting when we need to do that. To let you know. Hopefully when we go upstairs and go through some of the setups, this will all make a little bit more sense to you, a lot of what you can do with the control. Did I drop a screw? No, I didn't pull it. I'd never make it as a contractor. I'd always be looking for my tools, but fortunately everything's right here. They do have a lot of disconnects to bypass things, but when I'm looking at sensors and whatnot, you can't jump those out because they're resistance. Here's your screwdriver. Now, the same boiler over here with no domestic is our K-2 heating only. And this one has a front cover that comes off. And this one has an access panel on the side. We lowered the cost on that one, so we took some cost out of it. They actually have in here the space in between. So now you can see that looks a lot easier to service, doesn't it?
Yeah.
There's not as much in there. Now this one, we want to have 2-foot clearance on this side so that we can actually get in and be able to get into it. So
Guys, for those who don't see, there's like, plexiglass panel on this side.
yeah, they just put the plastic, but it's a metal one. What's the lowest gas pressure you guys run into out in this area at all? This will, yeah. This will fire.
6.
How was it?
This will fire all the way down to 2.5. 2.5 inlet gas pressure. This and the other one. Now, anytime you have a problem with a boiler and you want to know warranty, you want to know anything, serial number. If you call up, you give a serial number, I know who sold it. I know whether it's registered. I can see what the warranty's left on it. And if you can't find this plate, if it was gone, on this yellow energy tag, there's a little number there right down the bottom. I take a picture of it and blow it up. That's the serial number.
And we call that number you gave us on your card.
Huh?
That number on your card, that's the one we call if you have a question.
Yeah, my cell.
Okay.
And if you get, like I'm going December 12th out of the country, you get that message, don't leave one because I won't be calling you back. But they do have an 800
Tech
number.
support's been pretty quick.
Yeah, they get busy, and so it kind of gets tough. I have some cell numbers so I can bypass. This is a cable that plugs in. This is that Sage zone control. We do it in pumps and valves. So this comes down and actually plugs right in. This one, if you were doing low water cutoffs, we have a low water cutoff. Comes with a cable, plugs right in. So this one is a little bit user friendly. They took some of these features out of this one when they made that one over there.
Did they make a steam boiler for something like that?
We do steam boilers, gas and oil. So we do those, and if you guys run into steam, it'd be good to look at it, make sure you got the right boiler, because steam, a lot of guys are matching up what's right there, and you want to size it based on the radiation. I had a guy that actually installed a steam boiler, and it wasn't big enough, and what he did, he sized it based on his connected radiation. Well, they had a whole lot of other radiators, and they took them out. And they had great big mains. So there's things like that. And then when you are sizing the steam boilers, and they have a 2-inch main, heat loss of 2-inch pipe is 200 BTUs a foot. heat loss of 2.5-inch pipe is 250 BTUs a foot. I bet you know what the heat loss of 3-inch pipe is.
I bet you it's not going to be 300.
It's 303 or 302 BTUs a foot. 4-inch, 380 something. So I'd say 400 BTUs. So you can look at it. So if you had your steam boiler undersized and it was a problem, you can forget the elbows. Just get some of the big mains insulated. Just some of the run. And it drops it down to less than a BTU per foot. Just throw some insulation on that. Makes a big difference. And if you ever do steam, you can do any steam at all?
Yeah, some.
So, not a lot, but I have 2 I'm pricing right now.
So if you do steam and you go to start it up, they used to always tell me that you have to cook the system out. So you let the system run. You don't do that because what happens, you send all that wet steam out there, it loosens all the crap up and it comes all back to the boiler and you can't stop it. So when I wrote a paper on how to skim a steam boiler, and I just use Arm & Hammer non-sudsing washing soap. And basically what happens, if you get short cycling the burner on, off, you get water dripping down the top of the sight glass. You get bouncing water line really pretty bad. Or if you have uninsulated mains, and go out when you first turn it on, you put your hand on the top of the steam main and put it on the bottom. Which should get hot first? The top should, but if your bottom's getting real hot, I'm sucking water and it's all coming through. The other thing is, you get down the basement, it's the warmest room in the house. Everything's condensing in your mains, you're not getting any steam out. Or you get uneven heating. So you get steam that goes to that half of the house, it doesn't make it to that half. A lot of it's dirt in the boiler.
Right.
And so you just gotta skim it, get the oils off the top. And then I also have you pipe the boilers in with a shutoff valve. When you come up with your returns, before it goes in the Hartford loop, I put a ball valve and a drain valve below it. So I can dump all the condensate coming back. So you can skim the boiler, and then all the dirty condensate that comes back can go down the drain, and once it's clear, I then can let it go back into the boiler.
Are you supposed to blow it down at once a week?
Well, you should when you first put it in. You want to blow it down. If you have a float low water cutoff, more and more people are going to the probe low water cutoffs. So it's kind of tough, and people like the probes, but the only thing with the probes, there's nothing to blow down except you can drain. You can't get the surface stuff off. So when you do the floats, if they don't service it, and then you get mud around the float, the probe low water cutoff, it senses that there's water, and it doesn't shut down. It just runs. And then with the
Take that box apart.
you should take the probe out and clean it once a year. And then the other thing is they have those cycle guards. So the new ones, they run for so many minutes and then shut it off. So they let, in case you have foam in your steam, you got foam on top of the water line, the bubbles all go down, and now it just senses and makes sure it doesn't, because it conducts electricity across those bubbles. So the cycle guards, they actually lose some capacity for you too, because the boiler doesn't run for that whole hour. It shuts down. So you do lose a little bit, not that much, but just to let you know. So we'll go back up and we can do a little programming.